Hi guys, can you hear me at the back? Audible? Awesome. Okay, so I see a few of us walking in, and so how was the lunch? No response? Like it was pretty good. Already, okay. So in this talk, we will talk about how many of you are game developers? Game developers? Oh, web? No one, no one, no one, no one. Okay, that's not so good. But what we'll do is we'll try and keep it as simple as that. How many of you are JavaScript developers? Okay, so all of you can be a game developer at the end of the session. So that should be our goal now. Okay, and we will use absolutely all these tools that we will use is free of cost available, and it's an open source library that I'm going to talk about. So you can use it from any of the dev environment that you have set up right now, and you can create beautiful games, and you can sell that. You can package that into native containers as well. You might have heard about Cordova, or you can do it in different ways. Cordova is one of the ways, but you can actually put it on store as well. So in this talk, we will check that out, how we can do such stuff, and we'll also understand how many of you know about WebGL. WebGL. Okay, so all of you know about it, but you probably haven't used it. Used it as in developed anything on top of that. Okay, so a little bit about me before we get started. I'm Abhishek, and I work as a technical evangelist at Microsoft, and that's where I tweet, Narain Abhishek. So any questions post the session, you can tweet me over there, and I'll respond back. Right? And a thing which I missed out, and why I'm a game developer. So I'm basically a geek, and not just on a particular technology or a product, but anything which interests me. For instance, a couple of years back, Node interested me, so I probably looked into that. So whatever sounds nice, I just have a look into it. And game certainly was one of the things which I play a lot. So it made complete sense to look into some of those libraries which is available for gaming or 3D development, which people can use. And primarily, I work on web games, and and a vivid gamer. Talk about any game with me. Right. So in today's topic, we'll talk about 3D accelerated graphics with HTML5 and WebGL, and how this thing came into picture with the standards. That's awesome, and which will work across devices. And then we'll talk about a library called Babylon.js, and we'll move to Babylon only when we understand the complexities of WebGL. So we'll start with that, and then we'll look into performance considerations. Not a lot of gamers here, so I'll try and skip that part. This is primarily focused for when you're creating a 3D game and you really want to boil down to performance stuff so that it works on even the simplest or the cheapest of the Android phones. So you would look into such considerations, but that's okay now. We'll just learn how to write 3D code here or render 3D graphics here. Right. So this is the section 1, and all of you know about it. WebGL is a JavaScript API based on OpenGL ES2 standards, and it was standardized by Kronos Group, and it works perfectly well with Cordova. I have tested it, and I have deployed it on Android tablet as well, which was Lollipop. So it just works really well there, and it works across browsers. Whoever follows the standard, all the standard-based browsers, Mozilla, Chrome. You see this E sign? What's this? Any guesses? Wow. Okay. So that's not Internet Explorer. That's a browser called Edge, which came up from Microsoft. And the intention of this browser was to always keep updated, just like an app which comes from a store, just like Chrome, so that we can push in weekly updates with the web standards. So this certainly does better than what Internet Explorer did earlier. And let's get into WebGL and what you need to do while you use WebGL. So all you have is a canvas, HTML canvas, and then you need to do everything. You need to create shaders. So how things work in a game. Um, can someone guess what's the basic element or geometric shape using which all 3D objects are made up of in game? Triangle, triangle, that's correct, right? Triangle. So imagine if you see a 3D human being in any game, it's actually composed of small triangles, right? And what you need to know about is the vertex, where you place that triangle in 3D and you place multiple of those triangles, and then you finally make any geometrical shape. May it be a cube, it's made out of triangles and stuff like that, right? So you need to write shaders. Basically, shaders are those guys which will create those triangles, and then it'll, there are two kinds of shaders. One primarily puts the vertex where these triangles needs to hold, and then the other one puts how you put mesh on top of that, the lighting and stuff, because without that you won't be able to see anything. You'll only see lines, triangle drawn. So these are those shaders which you would have to write yourself while using WebGL. So that's a little bit of a pain, and if we all of us had to be a game developer at the end of the session, it certainly will be a difficult task to go the WebGL route. You have to work on geometry. You really need to be good at maths. That's my learning. So I should have done a little better while I was in my school. And then you have to manage the render loop. So game works in a loop. If you see 60 FPS, frames per second in a game, or 30 FPS, it's basically a loop which runs, which updates your code, updates your logic, updates your code, updates your logic, updates your code. The code part is updating the UI. So you have a UI update loop, and then you have a logic update loop. So this works in loop 60 times in a second, and that's how you play games, and you can interact with mouse or touch and stuff like that. That's a very basic of how games are done. So let's have a look at the simple code, and this code is not to scare you. So when I looked into WebGL first, it was a little scary. I thought game development is like real far away. And the tool which I'm using here is just for my comfort level. It's Visual Studio. There's a community version of Visual Studio which is available for free. You can use that as well. And this gives you a very nice, I would say, debugging experience for me. I'll show you that later. So that's why I use this. But you can absolutely use any code editor, anything, Notepad++, Sublime Text, anything with WebGL, or rather the Babylon library that we'll talk about. Right, so what you see in this project is I have a very simple two files, index.html, index.js, and in the HTML file, we start with a script. You see a shader VS, a script, shader FS, two different shaders here, and which will do a lot of mathematical calculations on where to. Okay, I'll probably zoom in. Is this fine? Okay, or let me do this. Is it good? Okay, so here will be a lot of calculations that you need to do for finding out the positions of the object that you will draw. So for each triangle, like if you're drawing a complex object which contains like 100 of those triangles composed of those, you got to run this loop to get the positions of each of those vertices of the triangle, right? So that's one thing which doesn't look so complex here, but there's a script reference, index.js, and let's try and have a look in there. So in this, just for simplicity purpose, I have like put in some of those basic steps that you need to go through to create a very basic triangle in WebGL. And you start with the canvas that you have as part of your HTML. We call it render canvas. That's the element that we'll use to render the 3D stuff. And there's a width setting, height setting of that. And then you go in initialize the WebGL. All simple till here. Right. Now, this is how it's different from other JavaScript programming. It's like how you work in C++ and you compile the code. A lot of things like that happens here with the shader. It's compiled, and there's a lot of code for the shader, which the node type, basically triangle, so 3 nodes types, and it gets the context of it, and then you have those shader initializations here. Looks complex. And then compilation of shaders into the program. Is that what happens? There is a linker which links this shaders with the shaders. And it's quite, I mean, to me it looks pretty complex. If I have to, I focus less on my business idea or the game idea, and I focus more on, how to get things done here, right? And it works fine. So when I run this, it's certainly, bunch of code does only this, right? It's kind of painful, like you put in so much of effort and then you get this. But certainly, if you need a very high, deep level of control, this is the way you go, because you have a lot of control over how you want to render things. But if you want to create a quick game, certainly this WebGL route would take you a little longer time unless you are a guru in this. So we will try and get back, simplify this code, and render better stuff little later with Babylon, right? So in this process, we just quickly drew a vertex, a triangle, and then gave a color to it, which was RGB 100, and then it looked somewhat like that. But in real 3D scenarios, what would happen is you would need to have a wireframe of a body, and this wireframe, if you see, these stuff over there, actually these are nothing but those triangles which we talked about. So all these wireframes are built out of triangles, so you will have vertex coordinates for each of those triangles, put in a particular file. It can be any 3D file. There are a lot of formats around, so you can use any of those. There's 3D, Studio Max, Maya, all of these guys emit this kind of a structure. So this is the basic wireframing. And then we have a concept of rasterization. So to make it look a little better, you have to fill in colors between those triangles. And then there's a process of flat shading. You give flat colors to that, and it looks exactly not like this. It looks a little better than this, but on the projector it's coming as this. But you do this flat color shading in each of those triangles to make it look more real, and then you do a garage shading. It's a guy who invented this shading, and which kind of blends those triangles and makes it look real good. And then finally you do a texture mapping. So you have a 2D texture like a JPEG, and you map it on top of that wherever you want. And this is how the monkey looks like now post the texture mapping. So it's like how we have the skin here. So that's the texture for this 3D object. And this is how 3D stuff works. And when you're using WebGL, you have to take care of each of these processes, right? So shaders, matrices, maths everywhere, like too complex. So actually, let's take the easy way, which is Babylon.js, and get rid of WebGL. And a little bit about Babylon. You can see a lot of releases. It's completely open source. If you want to add something to it, like export a library to this guy, you can do that. You can work on top of this. This was created by a few of our colleagues in France, and they actively work on it. So you can see it's a good traction that the web game development community has over this library. And we will get started with the code, but just to give you a brief, it's as simple as including the Babylon.js, that's the complete game engine with you. And that will take care of your shaders, creating shaders, your physics, any of those physics like gravity and stuff which you're applying in your 3D. It'll take care of those things. And then all you need to do is start with instantiating an engine from the Babylon engine and set the canvas where you want to render your context over there, right? So this is how you start with it. And then, of course, you instantiating an engine doesn't really make sense. So you put a camera there. Camera is the person who will be viewing that scene that you draw. And you will put up light, because without light, you will see everything black over there. And then you can draw objects like spheres, boxes. These comes out of the box with Babylon, and it handles the vertices stuff, all those things. The library does that for you. And then just run render loop, and you are good to go. So it has a lot of features. Like if you're a game developer and want to know whether it does alpha blending or can I draw dynamic meshes or can I put a dynamic text over my objects? All those things possible. So here's a list of that. A lot of things which you might not find here as well if you're a pro game developer over the web. And these are some of those objects which are pre-created by this game engine. So if you want to create a box, sphere, cube, plane, torus, torus knot, lines, cylinder, anything of those things, it's the primitive contains it. So you don't have to worry about it. Babylon will generate these. All you have to give is the size of them, what kind of mesh or texture you want to wrap on them, and stuff like that. Okay, so now let's look into a demo. And before I get into demo, well, how many of you are sleepy? The people who are sleepy are sleeping, so that's okay. Now let's see first a small demo. What's probably the capability of this engine? And I have put an audio, so you can render audio, you can render video, and let's see what we have. I have a small scenario, a 3D stuff built in this code, and what it does is a designer was the guy who actually built this whole 3D space, and what this game engine is doing is it's importing that 3D stuff built by a designer using there's so many tools. There's one free tool called Blender. You can use that to create these, and I'm just importing that guy and instantiating it with a Babylon.js game engine, right? And on top of that, we will add a few interactions, like on tap, click, those kind of things here. So now let me just add some volume here. Okay, so there's a background audio here. So you can see a big animation, and you can see there's a physics here. So when I stop, I take back a few steps. You can see on the top there's a cloud, and there's collision, of course. So I can't like pass through here. That's all fine. Now some interesting stuff here. There's a graveyard. Okay, and you see. I can interact based on where I am, and there's something called, you can't see here, I can see here actually due to the projector, you can't see, there's a grave, and on top of that grave there's Hamlet. So when I click on it, there's a skull and a skeleton of Hamlet, so it's very easy to render here. Once you have that 3D object, I can just bury him again. This Clippy, do you guys remember this? Microsoft Office? Okay, so that's Clippy. That's my cat. Forget it. This is interesting. This is this was the grave for i6. That's out of support now. So that's Internet Explorer 6 for you on that grave. Okay, so now we are in the world of standards, and we completely abide to standards, so we got to stick there. And this is the small stuff. Let's get started with this. And creating this isn't really a big challenge, right? And if you look into the code, we start with initialization. So we'll get back to this code a little later. Let's start creating some stuff for now. Okay, so let's here's a very basic web template, like how you create a web application in Visual Studio. So nothing to focus on Visual Studio here. It's nothing inside it. So when I run this right now, it does nothing. I'll start with instantiating the library itself. You see, there are two Babylon libraries, .js. I mean, I just had it here for your clarification. If you use the unminified version, the max.js, you will get proper intelligence with it, so development becomes much easier. So I'm going to use that here. So that's all cool. Now let's start with canvas. I should say render canvas, anything that you like. And this is where we will instantiate the engine, we'll set the context, this element, and everything gets rendered here. Okay, and let me close this guy. Now, this is all good. Now let's start with my scripts where we will start initializing the engine. So let me write the script code, and let's start off with an engine. Let's call this, you can call this anything. We'll call this as engine, new. I get this beautiful IntelliSense here, dot engine, and I can just go ahead and mention where it needs to render. So you can see the IntelliSense, if you can't read it, like just helps me out while I code. So it says HTML canvas element, canvas of type canvas. So I know that this is the canvas which I created on the top. So I'm going to give that render canvas. And then there is an anti-aliasing which you can forget for now. That works. That's just to ensure that it works on all browsers. We are done with the engine instantiation. Now let's start with creating a small scene. So I'll just go type. Okay, let me just go a little bigger here for people at the back. Okay. Similarly, I will just go ahead and create a Babylon scene, and I will pass in Babylon.engine. So whatever engine I created, so I can have multiple engines if the need be, or I can have multiple screens when I have level 2, level 3, level 4 game. So I can instantiate, I can put an engine to this, so which is the one which I created above, does this, right? So we're done with the scene. Now the important stuff is what you see is the camera. So I got to set the camera now. Camera equal to new Babylon. Now there are a lot of options here. You know what we see. It can be a fixed point camera. It can be an arc rotate camera. Arc rotate camera is like, you know, you specify XYZ coordinate, and it will rotate. You know, exactly like what do you call that? On the diameter of a sphere, if you draw, or a circle you draw, it will keep rotating there on that arc, which it draws based on what radius you select, right? So we'll use that. It looks nice. You can do a left, right. So we'll use one of those cameras. But there are plenty of cameras. You have a point camera as well, whatever you want to use. Now in this, I have to give it a name. So I'll call it camera. And again, there's some magic words. Don't bother about when you are not a full-time game developer. These are some of those stuff, whether you want, how you want to place camera, how you want the view to look like and stuff like that, alpha blending and stuff, it comes use over there, but we'll neglect it for now. So I'm just going to put value 0, 8, nothing to worry, you can try out these values, how it works. And then is the radius. I said it's an arc rotate camera, so whatever radius you give, it will always, you know, rotate across that particular distance, radius, right? So I will set this guy as 100. This is the initialization of it, but of course if you add controls of moving forward and back, it will change, but this is the initialization of it. So done with this part. Now is my target. So we created this. So I will give a 3D target, vector 3, and where you want this camera to be there. So we will set it initially maybe .0. Or you can place it at any vertex you want in 3D. Right now it's just 0, that's okay. And then pass the scene here. So we create a camera, all good. Now the next step is, if you want to control, like move back and forth, you will have to attach a control to this camera. So we will just do that. Camera attach control, and you are attaching, and you specify which HTML element. We are using render canvas here, so just set that guy. So which means now you will be able to interact with the camera in the sense you will be able to use the default movements of the mouse. Also, we will enable touch, so you can use that now. Without that, it will be a fixed cam. You can't move it here and there, right? So based on whatever the requirement is. Now, let's set up light quickly. New on dot. Again, in light, you have a lot of other options in what kind of light you want to set out to. Light which comes from a ray, we can call it as a point light here. So that's the point light which I'll use here. And set the name of the light. It can be anything, and the position of the light. This is pretty interesting. Now, this is where you would say, I want my light to be coming from, right? So it's very important. If you want to make it look like sun, you place it real far from the object. So we'll just go ahead and create that 3D vortex here. Vector 3 and specify maybe 20 or 20, and that's why XYZ. Okay, done with this, and then it's the same scene we are working on. Go ahead and done this. So now we have light. Now it's all good. Light's there. Let's put an object here. Let's put a very simple geometrical object, sphere, and let's create that. On dot mesh. So I can draw different meshes. If you see the options here, I have a lot. So I will create a box, cylinder, dashed lines, decal, disk, ground. These are those primitive options which this library gives me. So if I have any of these available which I want to draw, I'll use that. Create lines. Okay, and sorry, it wasn't create lines. Let's do create a sphere. Create sphere. Create sphere. Okay, name it something. Sphere. And then here's some important stuff like segments, diameter, scene. As I said, any of these objects are made up of triangles. So segments basically tells me how many of such triangles. So this will ensure that it uses more number of triangles if you have a higher segment value, and your objects will look more like those objects. Otherwise, it'll look little, D-shaped, triangle-ish kind of stuff. So you can put any value here for segment. For now, let's try it out with 8 first. Let's try 8, and then we'll change this later on. And I will set the diameter of the sphere. All good. And then finally use the scene where we'll render this. Okay. Now another important stuff is this will be a sphere, but we don't have a material, so we'll create a material, a standard material. Sphere is, as I said, it's just like a mesh. It doesn't look. It just looks like wired diagrams. And if you want to make it look like real sphere, we'll have to add a material to that. So just go ahead and create a new material. There's a standard material option, and I can put this as standard. So I can have different materials part of the same scene. Good. We're there with materials. Now I would want to have a color to this material as well. So we can put any of those diffuse colors, like for instance, I can put a diffuse color on top of this material, and it can be what color do you guys prefer? So I can suggest something in RGB. 100. This gives it a diffused color to that material. So I should have that material color as red now. It's RGB, so R is 1 now. All good. Now let me assign sphere.material to this guy. And let's start with the render loop. Engine run render loop, and we will use an anonymous function here. Okay, and in this we will just call the scene.render. Okay, I think this is good. Now we should have something running. Let's try this out. Oh, okay. So I didn't set the CSS correct. So let's one sec. I have that code here. This is just to set body HTML width 100%, height 100%, and touch action none, so that I can go ahead and interact it with touch as well. So the browser doesn't use its own libraries here for touch, right? So now what you see in the front is we didn't draw a plane where to keep this sphere to, but we fixed this sphere, so there's no movement here. Now what you see here is I can actually go ahead and rotate the sphere, right? And you can see the light I used. This is a arc. This camera, what we used here, we can go ahead and rotate the camera. So actually, it's the camera which is rotating while I move this, and I can also go inside, zoom in this particular 3D object. So it's a proper 3D. But what you would see is the curves of this sphere. It looks like it's an image, or it doesn't look that great, and it's because of that stuff. Which we talked about. Let me just go and change this to maybe 16 segments. That just adds, it eats little more memory for sure, because drawing more triangles there, but it'll make it look better. So now when I run the same guy in here, now you see the finish of that is much better than the previous time. I can rotate around this and stuff like that. I can interact with touch as well if required. So this is interacting with touch. It works fine, right? So this is how I draw a basic sphere. Now if I have to go, and this is just like 7-8 lines of code, instantiate engine, scene, objects, if you have any geometrical objects, put light on top of that, and it's very basic maths, not much here. And you can build this. So this is the real advantage of this guy. And I have a few stuff which I'll not. So now let's come back to the previous one where we had 3D content coming from somewhere. And this is that code. And if you look at it, it doesn't look complex either. It has the same styling, just to make it full screen. And it starts with the canvas. And what we are doing here is we are doing a scene loader, because it's 3D scene created by a designer using any of those 3D tools. It can be a renderer, and we are just importing the manison.babylon file, which contains all the vertex details, drawing details, images of that scene. So we are just loading that guy into this engine, and we are adding events for key up, so that we were going up and back. Basically, we have to move the camera forward and backwards, left, right. That's what we were doing it. And it's very simple if you want to apply gravity. Otherwise, what might happen is you might just go out of the box, up, down, right? So all you do is, in the same cam code which we wrote earlier, you can do a apply gravity, check collisions. Check collisions will ensure that you can't pass through an object. It'll always collide with any other collision objects, right? And that's all it does. Finally, it attaches the camera to the scene. So it creates that same stuff because it had a manison.babylon file which had the 3D assets in it, right? So you can take it that way. But if you don't have it, you can build all the geometrical objects that you have. You can even put texture on top of that. Now, before I finish, I'd like to show you, there's a beautiful playground. This is the tool I was talking about, Blender. And actually, this is a Babylon.js playground. This is available online, babylonjs-playground.com. You can go right here, and you can edit, you can play, instantiate the engine, and you can see it here, and you can make some changes here. This is a scene with a texture and a height map. Height map is lets you draw something of these things. So it's basically a world map, what you see here. And you can actually go ahead and play around with this. Based on height map, it has added the texture of the world map on top of that. So it looks like this. And you can start with simpler basic scenes if you want to learn that. So do we have internet? You for sure would need internet for this. So this is a nice place. If you haven't yet set up a Babylon.js file locally, you can use this playground. Nice place to learn, see different stuff, play around with the code. Now let me quickly come back to the slides before we close for QA. And I have a lot of other samples as well on Babylon. I think one of my favorites is okay. I have all these samples which we did, and you can always use that. This is for collisions and 3D multiple balls falling here with the collisions engine working with Babylon code. So you literally have to do nothing, just to add the different elements as colliders, and that it takes care of. Right. So I'm open for questions if you have any. And Babylon.js playground, you have all the resources out there for learning it as well. This is another 3D object which we are importing using the Babylon engine. And
I have a question here.
Yep.
Yeah. So actually, I want to ask, like, how much resource is this using? It's like I will run this thing on Raspberry Pi, say. The resource is very limited. Absolutely. So will it be like rendering properly, smoothly?
Yeah, so it's just like any other game engine, and we talked about how you build your 3D stuff with those triangles.
So say suppose we are not using 3D, we are using only 2D features.
Okay, yeah, so still you are drawing triangles, and not to get distracted. So it completely depends on how accurate you want your 2D things to look like, and I can play around with those number of triangles, and reducing that helps improving your performance. So it doesn't add a performance overhead on top of WebGL. It only tries to make it more performant in terms of doing better garbage collection.
Won't there be like a RAM issue?
In any 3D, there will be a RAM issue. Like when you're working natively with WebGL, and if you're not doing a GC properly, there will be a RAM issue, right? Each of these assets, it completely depends on this. If this asset is 20 MB, how can I make it less than 20 MB? I cannot. Right? I have to load that here. So my whole game with all interactions now will be 21 MB, right? So if you want to cut down on that, as the designer, you have to ask, boss, give me an asset with less number of vertices and it should be lighter, right? So it's not the developer. Developer can optimize it from GC side, how I ensure that I create less JavaScript objects and reuse more. That helps me out. But Babylon as an engine does that for you. So you don't really have to worry about performance here. So this is a nice looking skull. Hi. Right? So you can use it. You can zoom in it. This can be scary. Right? So right now, frames per second is very low because it's running in a debug mode with VS. So there's a debugger which keeps track of it. But if you run it in release mode, it'll be much faster here. Okay, to help performance, it certainly, if you are new game developer, helps you out with ensuring that GC and stuff works more efficiently. The engine does that for you, right? So, but your question to make it work on a low-end Android device completely depends on what assets you're using. If you're just using geometrical shaped assets, for sure you'll never have performance issues. The moment you start importing more and more 3D assets is when the issue starts creeping in. You had a 2D game, so it can work with geometry there.
Hi. I had a question about this. I think you have heard about Phaser and 3JS, right?
Yep.
So I was wondering, what are the strengths or weakness of Babylon when compared with 3JS? My specific use case scenario will be to implement specifically 3D models for web VR stuff, which I know is not there in Edge yet, but yeah, for those purposes. So it will interact with a lot of other APIs out of a browser. And in that case, or in any normal 3D cases where there will be heavy intensive 3D rendering going on, but like machine is not an issue, resource. In that case, what will be the strength or weakness? Comparing with 3JS and Babylon.
Okay, I haven't done a comparison of that yet, but when you mentioned about your scenario of interacting with any applications, this guy works in well. We have integrated this with many enterprise-grade applications to render 3D as well, but I don't have a direct comparison with the other library you mentioned about. Sure. So guys, any questions on Babylon? I'll take that offline. I'll just come down there. Just I'm available over the email or the Twitter. So just feel free to bounce your questions there. Thank you.